Let me record this. Okay, I'm gonna get started. So today we're starting 10.1, a new chapter. And since it's a new chapter, there's gonna be a lot of new vocabulary. So let's start with the vocabulary of 10.1. Oh my gosh, Luke, can you do that later, please? Hold on one second. Okay, so 10.1, we're in circles now. Yeah, that was my son. Okay, so we're doing circles. Definition of a circle is set of all points in a plane that are equidistant from a given point. So it's a given point and all the points that are the same distance. So all the points that are the same distance away from it. I didn't do a good job drawing that, but if you're to connect all those points, you would create a circle. This is in a plane. What do you guys think if it wasn't in a plane? Like it was free to go in all directions, what would that result? A sphere. Yes, a sphere. Okay, so that given point, this given point right here that we're talking about is called the center. So if we label it A is the center. And the way that we label or the notation for a circle is this, and it'll be circle A. And they will always tell you circle A, like A with the center. They're gonna let you know what the center is because you need to know where's the radius. Is this a radius? The only way you know if it's a radius or a diameter is if you know where the center is. Okay, so this is the interior, like inside the circle is the interior and exterior outside the circle. That makes sense. That's pretty straightforward. Oops, sorry. Okay, so more parts of a circle. Anyways. AB, let's label this AB. This is a chord. AB is a chord. And a chord is a segment whose endpoints are on the circle. Endpoints lie on the circle. So what's the longest chord in any circle? The diameter. The diameter is the longest chord in a circle. Diameter has to pass through the center. So we'll write diameter. Whoa. Diameter is the longest chord in a circle. And it has to pass through the center. Okay, so more parts. Let's use a different color. This is a secant. So this is a secant, which is a line that intersects a circle at 2 points. So it hits the circle 1, 2 spots. And then another one. This is, where should I draw this? like right here. That is a tangent. So this one is a tangent. Sorry, I didn't do a good job spacing this out. So a tangent is a line. Okay, sorry, I'm gonna start a new page. So this is a tangent. And this is a line. That intersects a circle at one point. So it kind of just like grazes the side, you know, like it just touches it right there. It almost looks like the circle's sitting. Oops, sorry. It almost looks like the circle is sitting on the line. That's a tangent. And that point where the line and the circle meet, that is called the point of tangency. So creative. Okay, some more vocabulary. Congruent circles. You could probably guess what that means. Congruent circles. This is if the circles have congruent radii. That's how you will know if the circles are congruent. Concentric. Concentric circles. Well, just by looking at the word, CON means together. Centric is referring to the center. So these are circles that have the same center. Circles with the same center. So they look like a target, a dartboard, I don't know. Those are concentric circles. And then the last one, tangent circles. And if you're wondering, like, tangent, is this the same as tangent, sine, cosine, tangent? Like in calculus, you'll learn how these are related, but we're not going to talk about it here. Okay, so tangent circles. So remember, tangent with a line, it's where they meet at one point. So these are circles that meet at one point. So, circles that intersect at one point. So what that looks like, it could be like this, where they touch there, or they meet like this. Those are tangent circles. This is externally tangent, externally, and this is internally. Questions so far? Oh, I lied, there's one more definition. Common tangent. The common tangent is a line that is tangent to two circles. So if we have two circles and there's a line that is tangent to that one and to that one, that's the common tangent right there. This is actually called the external tangent. External. You can go internal. Like this. Okay, like that. That's internal. Okay, so now let's go over two theorems and then we'll get into the examples. So the first theorem is the tangent line to circle theorem. These names, man, love them. Tangent line to circle theorem. It's pretty clear what's going to happen. So we have a circle and we have a line tangent to it. So this says that a line is tangent to a circle, if and only if. Do you guys remember if and only if? So this is a biconditional statement. So the converse is also true. The line is perpendicular to the radius of the circle. So what we're saying is if we have, here's our center, you need the center to know where the radius is. When you draw a radius to a tangent, it will create a right angle. The other way around is true too. This line is tangent if the radius is perpendicular, creates a right angle. So anytime you see a tangent, just know that you're gonna, and you draw a radius to the tangent, you're gonna create that right angle. They won't always label that right angle for you. So you have to know this theorem to solve some of the problems because it makes a difference if it's a right angle or not. Okay, the next theorem is the external tangent congruence theorem. I like to call it the two tangent theorem. So what this is, it's a circle. Oh gosh, my circles are really bad. I need my overhead. I miss my overhead so much. Okay, so we have a circle. And then we have two tangents. This says that the two tangents that come off are congruent. When you have two tangents coming off a circle and they meet at a point outside the circle, like this, kind of looks like a bird, profile of a bird. Those two tangents are congruent. Question so far? Oh, can you not see? Margot, did you miss something? Is that okay? Okay. Then we're going to move on to the examples now. All right. Maybe I should use this. I just want that big. Okay. Okay, find x. Okay, So the answer to this is x equals 12. This is a two-tangent theorem. These are congruent, so 4 plus 2x equals 5x minus 32. Okay, next. I kind of like using this. Let's use this. So we have a circle, we have this, and we'll label this C, D, B, A. We have circle A. That's important to know. BD is 16. CD is 24. Find the radius. Find the radius of the circle. Okay, so this problem, let's label everything that we have. So we have 24. We have BD is 16. And we're trying to find the radius. Okay, radius always comes from the center of the circle to the actual circle. We'll call it, I don't know, let's call it X. So AC is a radius. Isn't there another radius? AB is also a radius. And radius to a tangent, so CD is a tangent because it's hitting the circle at one point. That creates a right angle. Oh, so now we have a right triangle. And what do we do with right triangles when we know we're trying to figure out sides? We can use the Pythagorean theorem. So let's do that. Let's a squared plus, b squared, 24, equals x plus 16 squared. So x squared plus 576 equals x squared plus 32x plus 256. Remember, this is a binomial. When you're squaring a binomial, you do need to FOIL that. X squares will cancel out. Solve for x, x equals 10. Are we okay with that one? Why do we square it? We're using Pythagorean theorem. This is a right triangle, so a squared plus b squared equals c squared. All right, so next example. So let's draw this. There's a similar picture, A, B, C, and D. So AB is tangent to circle D. AB is 8, DB is 10. Find CB. All right, so for this problem, it's kind of tricky because you have to draw in the radius yourself. What happens when you draw a radius to a tangent? You create a right angle. Radius to a tangent creates a right angle. Okay, so AB is 8, dB is 10. That looks familiar. 8, 10. If you don't know what I'm talking about, then we could do a squared plus b squared equals c squared, and you'll get 6 for AD. AD is a radius. DC is also a radius. So that makes this 6. So that makes CB 4. Are we good with that? Okay, so let's move on from that. Let's talk about common tangents. Common tangents. So we're going to find the length of a common tangent. Common tangents. Oops, common tangents. Okay, so there is a way to find these common tangents. It does seem a little weird and awkward in the beginning, but as you keep doing it, it does get a little easier. So I'm just going to write like some guidelines. So draw the segment that connects the centers of the circles. Centers of the circles. Remember, common tangent is a line that is tangent to two circles. So you're going to draw a segment that connects the center of those two circles. You're going to draw radii to the tangent. This means that you're creating right angles. Because these two are, both perpendicular, that means they are parallel, right? So you can make a note parallel. Through the center of the smaller circle, draw a line that's parallel to the common tangent. You're going to create, this creates a right triangle, and then you can solve using Pythagorean theorem. It seems like a lot, it seems a little weird, but I promise as you do these problems, it does get easier, and it's not that bad. You might even be able to do some of it in your head, actually. Okay, so we're going to do our first example with common tangents. I'm going to draw it really big so I can't use my geometer. Sorry, it's going to look bad. Okay, two circles. Oops, okay. And then the common tangent is what we're trying to find. This is x. So I'm going to tell you the radius. This is A, circle A, this is circle B. So the radius of A is 10. The radius of B equals 6. And the distance between the circles is 15. Okay, so the first thing we're going to do is connect the two centers like that. And we know the distance between the circles is 15, so that's 15. Now, radius to tangent creates a right angle. Radius to tangent creates a right angle. These two are perpendicular to the same line, so that means these are parallel. Okay. And then from the center of the smaller circle, you're going to draw a line that's parallel to the common tangent. So we have this rectangle. Do we see that? There's a rectangle here now. We have this line that's parallel to the common tangent. And that creates, because this is parallel, this is a right angle, this is a rectangle right there. Since this is a right angle, this is also a right angle here. Now this is a right triangle. That little tiny triangle right there, that's a right triangle. Let's label our sides. The radius of A is 10. The radius of B is 6. So that means from here to here is 4. So here's our right triangle. 15, 4, and because it's a rectangle, if this is X, this is also X. So this is X. Now we could use Pythagorean theorem. I'll give you a moment. Okay, so you should get X equals 14.5. All right, I'm gonna give you one to try by yourself. So X, the radius, this is A, B, radius of A is 9, radius of B is 6, distance between the centers is 20. So after a certain point, I think you don't even need to draw in all those segments. You could maybe work it out just by finding a pattern. You will see a pattern as you do this. Okay, so for this one, oops, it's gonna look just like the other one. Radius to tangent, radius to the tangent, right angle. Join these centers, which is 20, and this is 9, this is 6, and then we're gonna draw the line parallel to this. Okay, so a lot of people will draw the right angle here where the center is. The right angle is right there, right here, because this is a rectangle and the right angle, a right triangle, and that those two have to be a right angle together like that. Okay, oops, that's a right angle here. Okay, so this is 9, this is 6. Because it's a rectangle, this portion is 6. That makes this portion 3. So our right triangle is now 3, 20, and X, because this is a rectangle again, that's X. You should get 19.8. Okay, we're gonna do one last problem. This is, so far we've done external tangent. We're gonna do an internal tangent now. The process is the same, but the picture looks different. Sorry, I'm gonna do this on another page. Need more room. Okay. Okay, so this time we're going to go internally, which means we go, oh my gosh, shoot. Oh man, that's bad. Okay, I can't erase that, sorry. Okay. So call it A and B. Radius of A is 10. Radius of B is 4. The distance between the centers is 18. Okay, so it does look different, but it's pretty much the same idea. We connect the centers, so A to B, and that's 18. Let's do radius to the tangent. Radius to a tangent, you create a right angle. That's 10. Radius to the tangent creates a right angle, 4. These are parallel because they're perpendicular to the same segment. So they are parallel. Remember we had that rectangle and a right triangle? So we still have that. We have a rectangle, but the rectangle is going to start like the other one at the center of the smaller circle and parallel to this common tangent. Sorry. So through the center of the smaller circle, parallel, and we do need a right triangle. So let's finish this off here. This is a rectangle right here. Rectangle, rectangle, rectangle here. Okay, so this time our right triangle is this big one right here. That's our right triangle. So this side is 10. This side is 4. It's a rectangle, right? So this side is 4. This side is 4. This side is x of the rectangle. Then this side is x of the rectangle. So our right triangle now is x 18 right here, the distance. And then this whole thing is 14. So before we were subtracting the radii, now we're adding the radii. Okay, so I'll give you a moment. So Pythagorean theorem, you should get 11.3. I think these are fun. The more you do it, it gets quicker and you don't have to draw as much, and you know you just have to add or subtract. Yeah. So the next time you have like a problem with the chains on your bike or something, you can figure things out. Questions? All right. So this is the end of the lesson. I will be posting this on my YouTube channel. If I sent out an email, I don't know if most of you got it, but your homework, they're all going to be due when classes resume. So, I mean, you just pace it however way you want to do it. I'm going to be teaching a lesson every day. But that doesn't mean you have to have your homework done by then. I mean, you could just take your time and, you know, watch a video every other day, or I don't know. But yeah, so pace it out and for the next 2 weeks, even during spring break, I guess. But yeah, so I will see you guys tomorrow. Bye.